12.58 volt. Okay, let's do another one. In the circuit shown, find A, the current in each resistor, the potential difference between points A and B, the power supplied by each battery. Tell me if you remember, what is the equation for the power supplied by a battery? The power supplied by a battery is its EMF multiplied by the current that flows in that cell or in that battery. Okay, let's start by assigning names to each corners. This is A, this is B. Let's call this C, this D, this E, and this F. Now, since this diagram, I don't think it is going to come completely on the camera, so please keep the PowerPoint with you, the same diagram you can refer. Alright, let I1 be the current leaving the battery on the right. There is a battery on the right, a battery on the left. So let's assume that I1 is the current leaving the battery on the right. This one, that is I1, and that I1 flows through the 3 ohm and reaches A. And let I2 be the current leaving the battery on the left. If I2 is the current leaving this battery, that I2 will flow through the 4 ohm and reach A here. Now that means I1 will reach A, I2 will also reach A, and they will combine together and flow through the 6 ohm. Alright? They meet at A and I3 leaves A. So let I3 be the current in the 6 ohm. I hope you are following how I'm setting it up. Let I1 be the current that leaves the cell on the right. Alright. So I1 is the current that leaves the cell on the right that passes through the 3 ohm and reaches A. I2 is the current that leaves the cell on the left, passes through the 4 ohm and reaches A. They combine and leave A as I3. I3 is the current that passes through the 6 ohm. Okay? Applying the first law for junction A, you can see I1 reaching there, I2 also reaching there, I3 is leaving. We have I1 plus I2 minus I3 equal to 0. That is the first equation. And now let's apply the second law to the closed circuit loop A, B, D, C, A. Now that will be A, B, D, C, A. It's a counterclockwise loop. You can see the direction of the loop is the same as the direction of I1 and the direction of I3. You notice that? Watch it again. The loop is A, B, D, C, A. It is the same as the direction of I3 and the direction of I1. That means the potential drop across the 3 ohm, which is 3I1, is positive. The potential drop across the 6 ohm, which is 6I3, is also positive. And the loop is traced out from the negative to the positive of the cell. The potential drop across the battery is negative. We get 3I1, the potential drop across the 3 ohm, plus 6I3, the potential drop across the 6 ohm, minus 12, which is the potential drop across the cell, equal to 0. And we can write it like this: 3I1 plus 6I3 equal to 12. That is our second equation. we need a third equation. Let's use the closed loop EABFE. Well, tell me how that is going to be. EABFE is in the same direction as I2 and in the same direction as I3. That means the potential drop across the 4 ohm is 4I2, that is positive. The potential drop across the 6 ohm is 6I3, that is positive. And the potential drop across the cell is negative 12. So that will be 4I2 plus 6I3 minus 12 equal to 0. Rearranging them gives me 4I2 plus 6I3 equal to 12. What you now need to do is write these three equations in the proper standard form. In other words, it will be 1I1 plus 1I2 minus 1I3 equal to 0. And how will this be written? 3I1 plus 0I2 plus 6I3 equal to 12. And how will this be written? 0I1 plus 4I2 plus 6I3 equal to 12. There you are. Rearranging these equations, you have I1 plus I2 minus I3 equal to 0. This time I did not write the 1. It's not necessary. You know this is 1, and this is negative 1. And the second equation is 3I1 plus 0I2 plus 6I3 equal to 12. And the third equation is 0I1 plus 4I2 plus 6I3 equal to 12. Now you know how to deal with this. Make the matrix A with the coefficients on the left, matrix B with the coefficients on the right, and find the value of A inverse multiplied by B. And when you solve them, you will get these values. I1 equal to 0.89, I2 equal to 0.67, and I3 equal to 1.56 ampere. Alright, try this, do this on your own, don't leave it. You must do the matrix now and solve and make sure you get these values. Okay, let's look at another one. Well, we haven't finished. We measured the current in each resistor. We need to find the potential drop across the point AB. Well, potential drop across the point AB is the potential drop across the 6 ohm resistor, which will be V equal to Ri. So current in the 6 ohm resistor is I3. We calculated it as 1.56 ampere, and therefore the potential drop across that will be V equal to Ri. That is 6 ohm multiplied by 1.56 ampere. That is 9.36 volts. So once again, the potential drop across the point AB is the same as the potential drop across the resistor. Now we need to find the power supplied by each battery. The power supplied by a battery is its EMF multiplied by the current. Therefore, the power supplied by the battery on the left is 12 volts multiplied by I2. We know the value of I2. And the power supplied by the battery on the right is 12 volts multiplied by I1. The current in the battery on the left, I2, is 0.67 ampere. Therefore, the power supplied by this battery is P equal to E times I. that will be 12 volt multiplied by 0.67 ampere, that is 8 watt. So the battery on the left supplies 8 watt of power, 8 joules per second. The current in the second battery is I1 equal to 0.89 ampere, and the power supplied this battery is P equal to E times I, that will be 12 volt multiplied by 0.89 ampere, and that is 10.7 watt. The total power supplied by both batteries is 18.7 watt. And where is this power used? These powers are used up in these cells. In fact, if you find the power dissipated in each of the resistors, 4 times I2 plus 3 times I1 plus 6 times I3, now the power dissipated in each of the resistors, if you calculate separately, that will be equal to the total power supplied. If you want to calculate the power supplied by each resistor, you want to know the potential difference across it, or you can calculate it as I squared R. The power dissipated on the 4 ohm will be I2 squared times 4 plus I1 squared times 3 plus I3 squared plus 6. Check whether the sum of that will give you 18.7.